So now we come to two of the major theorems and properties that we're going to be using in this lesson. The first one is called the triangle proportionality theorem, or also known as the side splitter theorem. You can see that we've got a picture of a triangle with the third side and this segment within the triangle being parallel to the third side. And the theorem reads that if a line parallel to one side of the triangle intersects the other two sides, then it divides the two sides proportionally, or in other words, divides them in the same ratio. So in this case, we're given that RS is parallel to TV, and this has been shown with two arrows. So our conclusion is going to be, well, the other two sides are divided proportionally. So that means, what are the other two sides? OR was one of the other sides, and OS was one of the other sides. These sides are now divided in proportion, which means that this line segment TV has divided OR and has divided OS. So we have that the ratio of OT to TR, OT to TR, is equal to the ratio of OV to VS, of OV to VS. Notice I've written these in measure form because we're talking about the length. And that is true for all triangles. And we're going to be applying that formula in just a moment. But a similar theorem also holds for parallel lines. So that if we have three parallel lines, in this case we've got three parallel lines, intersecting two different transversals, and here you can see we've got two transversals, then they divide the transversal proportionally. Interesting. Okay, so that if this first transversal has three parallel lines that intersected, it has been divided into three line segments. The one that's from the top line to the bottom line, which is DG, has been divided into DO and OG. And similarly, on the second transversal, the largest line segment, which is CT from the top to the bottom, has been divided into CA and AT. So if we're given that DC is parallel to OA is parallel to GT, which is what these arrows are showing, these parallel arrows, then we can conclude that DO to OG is going to be the same ratio as CA to AT. So let's write that down. DO to OG equals CA to AT. Okay, this is very similar to the conclusion of the triangles up here. In fact, if D and C met in the same point, we would have the side splitter theorem. So these theorems are very, very closely related to each other. Make sure you copy them down, and we're going to go ahead and start using these in the next set of videos.